Okay, let's see what we can do here. They call this chapter security. What it really is access control lists. And if you want to play on the computer, that's fine, but when you get ready to do access control lists, you're not going to know how to do it. And that's up to you. And you can bet your sweet bippy I'm going to ask you how to do it. And you can bet your sweet bippy that when you go to take the CCNA, they're going to ask you to do it. And I can tell you for a fact they ask you to do it because the last time I took a CCNA, it was the first question that I had. Write an access control list. Not only did they say write an access control list, they said write an access control list that uses 5 statements to do this activity, this particular thing. So, yes, this is the thing that not only is going to serve you here, the things we're going to talk about now, as you go on into routers, it gets involved with how you actually set up a firewall. Now, if you're going to use the iOS as a firewall, you're probably not going to sit down and write all of these access list statements at the command line because a firewall configuration probably has somewhere around 400 access control list statements. Yes. That's when you use the SDM that he's referred to, the security device manager that he's referred to several times in the book. And there is a demo, an SDM demo, that's available in your labs link. You have to have that version, and you have to follow the instructions. There's a file that you use that it actually goes through, and you can use a demo on how to use that. The SDM is not used in the CCNA yet anyway. Command line commands are used in the CCNA. If you go for the CCNA security, the SDM is used. So in this one, the topics covered, types of attacks, and if you will look in your book, we'll talk about a couple of them. He's got like 2 or 3 pages worth of attacks that are used against entities, activities. And then mitigating attacks, what can we do? Mitigating attacks, what we can do is to just say no. Who are we going to allow through the router? And when we're talking about access lists, we've got standard, extended, named, monitoring. There are other access lists. These are the ones that we're concerned with to start out with. The named is just a convenient way to do the other 2 access lists. What it does is when we get into them, the first 2, the standard and extended, have numbers for names, and then if you want to have a named list, you can say that you want an IP access list, standard or extended. Again, named is just a way to do the same thing, except you use a name instead of a number. A little bit easier to keep track of. And then monitoring access lists, and the monitoring access list is another one of those really tough commands, show access lists. It'll tell you what your access lists are and any activity, any thing that access list has done for you, like to deny access to something. So this is something that shouldn't take me very long to talk about, but does require, in order to understand what's going on, and I've got some demos to do at the end, what's going on, you really got to do them, you got to write them. Access lists is one of those things that people kind of, the eyes roll up in the back of their head when they start writing them. They're not that difficult to do. But we are going to revisit wildcard bits. Wildcard bits, basically anything that's a 0, check it. If we had a 0.0.0.255, which says that we're going to do something to a Class C subnet. It says check the first octet. The 0 says check the first octet. The second 0 says check the second octet to see if all of the bits, the ones in the zeros, match. Check the third octet. The 255 says I don't care what it is. It can be anything in that range. The 255 is the ignore when we get to those things. So this is just what are we going to do. And this is kind of what most of the things untrusted look like. Untrusted network, perimeter premises router, sometimes called the filter router, which filters out some of the traffic. Goes into the DMZ, and this shows a 3-legged firewall. Some of them are, some of them aren't, depending on which one you buy. And think about what you're going to do with any of these firewalls. A three-legged firewall, once they've compromised the firewall, they've compromised all parts of it. You could put a switch between the external router, the filter router, the one that goes to the internet, and the firewall, and just have a switch in here and have your DMZ assets. DMZ, demilitarized zone, just like in the military they call it DMZ. This DMZ, this filter router, allows some users, and in many cases all users, to access certain resources. If you had a web server out here, this shows a web server and a mail server. If we had a web server out there and we were trying to sell stuff, who do you want to be able to get to your web server? Customers. That would be like everybody and anybody, right? But, no one. Dustin doesn't want to make any money. Dustin wants to. He's seen those advertisements. They used to have advertisements that say die rich. Now they've got them that say die broke. What most of them say is that when you die, you should have enough money to bury you, and that's it. So that's what Dustin wants to do, except he wants to get poor early by not having any customers. But the rest of us want to set up this router so that we allow everybody to get to our web server in order to see the products and buy the products. That's what access lists are going to do for us, to set it up so that they can get to only the services that we desire. Port 80, maybe port 443 if we're going to use secure purchase. We'd have to have those two ports and only those two ports available to everyone, anyone. And Andrew said, who we want to be the customer? We want everybody to be the customer, generally, because your objective is to sell things, except for Dustin. And the mail server, who are we going to allow to get there? And you probably would say, hey, we only want the people that have accounts on the mail server. That becomes a little more difficult to do in this case, but we're only going to allow access to the protocols, to the ports that we want users to be able to get on our mail server. That could be the POP, the SMTP, could be port 80, could be 443 if you're only using a web interface, could be 143 if you're using IMAP. All of those things that we've been going through, the ports and what's in the header and those kinds of things, this is where it really starts to come into force. What are you going to allow through the router? One of the things about access control lists, and I keep saying through the router, any traffic that's originated on the router is not going to be susceptible to the access control list. ACL's access control lists only affect things that go across the device, come into the device and go out of the device. So they manage the traffic that flows through the device. The attacks, and again, the attacks he's talking about, application layer attacks, auto routers, backdoors, denial of service attacks, and there go on and on and on. Again, in the book, and you want to take a look at those, we'll address some of these in more detail when we do security. And we'll try to simulate some of the attacks in the security class. One of the most prevalent one is the denial of service, or the distributed denial of service, and it uses part of the TCP protocol, because what happens when you initiate a connection from one location to another? You go to a web server. And we've already gone through the initial. We checked to see if it's local or remote, and we've got to the default gateway, and now we're at yahoo.com. What's the first packet that you sent to yahoo.com or google.com or anything.com, org.net, edu, whatever? What's the first thing that you send to establish the conversation? Or are you going to have to go back to networking one? Huh? How about a send packet? What starts the conversation? Synchronization says, hey, I want to have a conversation. And what does the server send back? Acknowledgement, as well as its own send packet. What happens if we then don't acknowledge its send packet? It keeps on sending. It waits. It waits. And what happens when it's waiting? Can anybody else connect? So how can we do a denial of service attack? It's called a SYN attack. So that you send packets to a web server or whatever. They send back the SYN ACK, and you just say, no, I think I'll just not finish this connection. And the reason that works is they use relatively small buffers because they didn't expect this kind of thing. Eventually it will time out. But if you send hundreds, thousands of these send packets, you can tie up a server with not a whole lot of attack. The distributed denial of service comes from a single location. Distributed, where you send the Trojans out all over the world, or whatever's out all over the world, and you get a lot of people in your army. One of the things that access control lists can do for you, if you filter going out as well as coming in, it can prevent you from your company from becoming part of one of these attacks. What information are you going to allow in and out? Will, again, the security will do more of those kinds of thoughts, those kinds of setting up, modeling, that kind of activity. What are we going to do with these things? But there are lots of things that we can do with it. Mitigating attacks, IDS and IPS, and I think we refer to those things, and it's about as far as we're going to hear, refer to those in networking. The difference between an IDS and an IPS, IDS is intrusion detection system. It detects an attack, and it says it reports to you that you had an attack. The way that I've seen this described is that you've got a couple of techies standing around the water cooler, and one of them says to the other, hey, did you see that really cool attack that we had yesterday? That's what an IDS does for you. An IPS is an intrusion prevention system. It will take action to stop the attack. So the difference between those two things, and they did ask the Network Plus, if you're taking Network Plus, they did ask that question on My Network Plus. You had to distinguish between an IDS and an IPS, what they do. The other one, stateful iOS firewall inspection engine, and this is something that we can use on a router. It's a really simple command, and we'll do it when we've got some demos to do at the end of this thing. What the stateful says is that if you initiated a connection to wherever from outside in, when you go through the iOS, through the router or firewall, it creates a little access control list that says the answer can come back. If you haven't enabled the stateful, you've got to filter each one. And if you have a don't let anything in, it won't let anything in, including the answer to the question that you ask. It's a one-line command in order to turn that on. So we'll look at that, do that. Firewall voice traversal to allow your voice over IP connection so that your telephone system works. ICMP inspection. ICMP, we normally associate with ICMP ping, trace route, ping primarily. And the ideal world is that you can ping everybody and they can't ping you, so you know if they're alive. There are other things that are part of the ICMP protocol. Network unreachable, host unreachable, packet expired en route are all ICMP messages. So you may want to filter ICMP instead of turning everything on or turning everything off. There are parts of it that you really do want. You probably want your ping packets to go out. You probably don't want echo reply on your external interface. You may or may not. That's one of the things that hackers use in order to identify available hosts so that they know what to attack. If it's not a live host, then what's the objective of attacking it? Authentication proxy. This would require authentication before you could actually go through the firewall. And there are a number of devices that will work to do that. Cisco incorporates some softwares that allow you to do that. When I was working at Blue Ridge Behavioral, they had a piece of software that was on the routers, on the firewall actually, that filtered by group who could get to individual websites, but specific websites, what time of day they could do. One of the things they had in one of the buildings was that the guards wanted to be able to get the internet. Well, the guards are supposed to be walking around the building to be sure the building's secure because it's a medical facility. Mm-hmm. What they did was give the guards 1 hour of internet time a night. So you can filter to that level. more or less. Lots of filtering can go on. A proxy is actually something that acts for you. That's a little bit different, the authentication proxy. But those are the kinds of filtering that we can do. That's beyond the scope of what we're going to do in this course, because what we're interested in are the two most basic access control lists, the standard and the extended, where we're going to do it at the command line. These others get the authentication and the who can do what when gets a lot more involved than we're going to do. If you want to do those, after you get your CCNA, go to your CCNA S, your CCNA security. It actually is a lot more fun. And it was a whole heck of a lot easier than the CCNA, I'll tell you. Purpose is used to permit or deny packets moving through the router, going across the router, back to that figure that they showed. Who do we want to be able to get to our web server? The answer would be, except for Dustin, we want all of our customers to be able to get there. Dustin wants to starve to death early, young. But we can do that with access control lists using permit and deny packets. And I know that he's going to have it in here. When we start doing these lists of who can get where, remember, in an access control list, at the bottom of the list is a statement that you don't see that denies everybody everything. So if you don't explicitly permit it, it's implicitly denied once you apply an access control list. We had an incident here that somebody in the building was abusing the internet. So you assign them a static IP address and just say, hey, they can't go. And that's really easy to do. You just deny them everything. Except that he forgot, after he put his deny statement in, forgot to give a permit statement. If you don't have a permit statement, you got to deny, and then you got to deny everybody everything. You laugh. It's going to happen. But plant this seed. You have to have at least one permit statement in an access control list. If you deny everything, the implicit deny at the bottom, you've just denied everything. Yeah. Well, it was like, nobody can get to the internet. Oh yeah, I forgot to let them back in. But those kinds of things. Permit or deny, VTY, virtual terminal. When we see VTY, we think Telnet SSH connections. And this is one of the things that if you are a network administrator and you leave 30 minutes, 40 minutes, an hour, or even 15 minutes away from the location where the devices are, and on a Saturday morning something needs to be done, do you want to get up and drive into work, open the building up, reset the alarm, go in and do all the other stuff? Or do you want to be able to get up and Telnet or SSH into the device to do the things that you need to do? You probably, if you're like me, I just assume do it remotely because I don't want to drive there. There are other things that I want to do because it's going to take you some time to get up, get dressed, drive there, do the 3 minutes worth of work that you've got to do, and then drive the 45 minutes back home. But do you want everybody, do you want Andrew being able to Telnet into your routers? I know he would erase everything for us. So what we can do is apply these access control lists on the Telnet connections also that only allows us to Telnet to the device, denies everybody access to it. And Cisco has this really cool thing. When you've done these things and the passwords and you haven't gotten the password, when you miss the password 3 times, what does it do? It says, it automatically says, bad secrets. No, it doesn't lock the account. And if you hit enter, what do? You do it 3 more times. And it says bad secrets, and you hit enter, what do? 3 more times. It doesn't lock you out. You can configure the routers so that it'll lock you out. Again, part of the CCNA security. But it doesn't by default do that. They don't default by do that. You can try it forever unless you as the administrator go in and configure the router to lock the logon after a certain number of failures.
Yeah, because I would imagine that would be a security.
It is a security. I mean, it's got to be a security issue, doesn't it? Well, if you just do just set up a piece of software that does a brute force attack. You just keep trying password after password after password. You'll eventually get the right password, exactly. And then if you use something really clever, you know, like password, it may not take as long. But I digress. Create dial on-demand DDR, interesting traffic that triggers dialing to remote locations. This is for, and there are sites that are set up that actually do use dial-up connections to remote location. Don't have a high-speed connection, whatever else. Little traffic, very little traffic every day. Access control lists identify what's called interesting traffic, which would then you define in an access control list which traffic will initiate a dial up, and it dials the remote location. There are cases where users have done that, set up the DDR, say, oh, we're going to save a lot of money by not buying a high-speed connection, except they forgot to eliminate broadcast traffic as part of their access control list, and wound up with really big phone bills in the first month. All of those things can be used, access control lists can be used for. So we can use them to filter what goes across the router. Again, what originates on the router is not affected by this. We can use it to control who can connect to the management end of the router with the Telnet and SSH connections. And we can filter or create access control list that defines interesting traffic that initiates dial-up connections to remote locations. This is obviously out of a different one. Access lists, says that they're everywhere. What are they? They're a list of permit and deny statements. And that's all they are a list of permit and deny statements. So please don't roll your eyes back in your head when you start writing these things. They have a specific syntax, and I would recommend when you use that specific syntax that you use the question mark.
You can do that.
Really handy.
You can do that with Internet Explorer.
Do what?
See access and deny.
Yes, you can. The permits, and again, you have to have at least one permit statement, because at the end of this thing is the implied deny everything to everyone. So this one says permit 192.168.2.50. You'd actually have to have a little bit more information. We'd say permit, and we would have to say host, or we would have to have a wildcard bits. What would be the wildcard bits for a host, an individual IP address?
Which IP?
192.168.2.50. What are the wildcard bits? Doesn't matter what IP. What are the wildcard bits? What checks everything? Huh? 0.0.0.0. Or if you have hosts, no. You're getting 255s, and 255 says, I don't care. What if I did 0.0.0.255? What would it then allow in? Would it allow that host in, or would it allow that whole subnet in? The whole subnet. So for a host, there are two ways you can do it. One is my preferred method, permit host, type the word host, 192.168.2.50, or you can say permit 192.168.2.50 0.0.0.0. Just seems to me it's easier to type host than all those 0 dots. Deny 192.168.1.0/24, and I don't think it'll let you use that syntax. Here, if we're going to deny the 192.168.1.0 network, the wildcard bits would be 0.0.0.255. We'd say, check to see if it's 192. Check to see if it's 168. Check to see if it's 1. And I don't care what any of the other digits are. That means it'll allow anything on that subnet. Permit TCP port, and these two up here, the first two up here, would be the standard list. The standard access control lists can only be used to deny or permit a source IP address. They don't discriminate based on TCP service. The extended lists do permit TCP port 84, and this is just written in English, 201.1.1.1, and we'll go through creating that structure. I've got a little handout that I've got to find and I'll give to you. It's called the anatomy of an access control list. It just goes through the whatevers. It lists the steps for you. Yes?
I take it, when you do your access list, one of the things that we have that has issues is you have to permit first before you deny.
No, you don't have to permit first before you deny. And let's go through that. Because the order, glad you asked the question, we'll talk about that now. There'll be some here. The order is important. What if we wanted to deny our bad guy? Well, who can be the bad guy today? Dustin is abusing his internet privileges, and he's out there surfing porn. Okay?
That wouldn't surprise me.
That wouldn't surprise you, but he's turning red now. Maybe it's what he's doing. But if we did the permit everybody else before we did the deny Dustin, what's going to happen? He's going to be part of the crowd that comes in with the permit. So the first thing that we would do would be to deny his, we'd have to put a static IP address on here, but we can do that. But the first thing we would do would be to deny his IP address. Once we did that, we have to have a permit statement, otherwise we get the implied deny, which would then deny everybody else. So then we can permit the whole subnet after that.
Right.
The way these things, give me just a second, the way these things work is you start at the top of the list and you go down, and once you find a statement that applies, you use that, and you don't look any further down the list. Now, I'm sorry, go ahead, Andrew.
Well, if you deny his IP address, can't he just renew and get a new IP address?
Not if we've put a static on and we locked the computer down so that he can't change his IP address.
I know there's another method besides the IP address. Can't you also deny the MAC address?
You can. Yes, you can. You can deny the MAC address. And we could, Yeah, but that's beyond, again, that one's beyond CCNA. You can use MAC. There are a number of different ways you can do it. You could actually use host name. If we used some of the other authentication methods, I mean, there's some ways to do it in Active Directory also, so that we could actually lock him down there, stop him there. But what we're talking about here are how to filter on routers. And after we denied Dustin and he got to the one at the top of the list that says, hey, you can't come in, then we would have another statement that said, okay, everybody else, it's okay, you can go through. That's where we would have to have the permit statement. If we didn't, at the end of it is what's called an implicit deny, which automatically denies everybody everything. And if we did our permit statement first, and we did the whole subnet, because it'd be really difficult to write that statement to avoid his specific address, then he would come in with the permit. He would never get to the deny statement. So the more specific statements in the access control list need to be at the top of the list. The ones that are used the most need to be at the top of the list. If you've got 1,000 statement access control list, it's got to go through everything and every time until it finds something that applies. So order does become important in these things. Order does become important. The extended list, the permit TCP port 80, permit all TCP traffic, those kinds of things are what are called extended access control lists. The extended access control list, you can do a source IP and a source port and a destination IP and a destination port, so that we can actually control that by service by TCP port. Or if you want to do all of the services, which is everything on a particular address, is just use the IP. IP tells it from one IP address to the other, but we can use a source and a destination on extended lists. Only source addresses on standard lists. They can be used for access control, NAT, and again, this is not mine. Quality of service, demand dial routing, which you talked about, policy routing, which again is beyond the scope of CCNA. Route filtering, and he says making French toast. Not really, but you can use them for lots of different things in order to control who can get where. Even in this building, there is some filtering that goes on between the networks, because who can get from which network to the other network? Do students really need to get onto the admin network?
Yes.
For what?
Anything and everything.
Anything and everything, like what? Come on, give me a good one.
I'm too lazy.
You're too lazy. Why would you need to get onto the admin network other than to do things that can get you arrested?
He wants to be able to look at his porn.
He wants to be able to look at his porn. That won't help him any. Can we keep one network from connecting to another network? Sure. That's one of the things that you want to use it for, is the isolation from that perspective. So that if you have payroll, who do you want to be able to get on the payroll machines? Not Dustin.
Well, of course, you're going to get your virus in your system.
Going to get the virus in our system. That's right. So we're going to really isolate him. Huh? But you don't want all of your employees to be able to get probably to the network maybe that that finance is using, that the payroll people are using, because people are going to keep trying to attack those things. Add a couple of zeros to your paycheck. Exactly. That's why we're going to filter who can get there. When they first set up these printers up here, they had a filter on who could get there, the faculty printer. You couldn't get to it from the classrooms, which kind of was painful for me because I had to go someplace else to print stuff. Then I just quit printing stuff. Actually, they changed that. This is, hopefully, maybe simplistic, but what happens here? What happens here is you've got the sentry that checks the packet, and it's going to check the TCP IP header information. That's what we're looking at right now. Yes, there are other filters that can be done at other layers of the OSI model, but right now we're at layer 3 and 4. We're looking at TCP port and IP address. That's what we're filtering now. So you've got this little sentry that when a packet comes in says, let me see the header information. And it compares that to the access control list. Once you write the access control list, by the way, it doesn't do anything. It just sits there. You have to apply it to an interface. And you apply it to an interface either inbound or outbound. And the way that the guy that did these things says to imagine your torso is the router and hold your arms out as the interfaces. And if it's going away from your torso, it's outbound. If it's coming toward you, it's inbound. So what you really can do is just, if you don't want to hold your arms out, use your fingers. But away, are you applying it inbound or outbound? And you have to tell it which direction to go. And that can be significant, because if you apply it inbound, you may deny a lot of things, and we'll look at a topology here in a few minutes. You may deny users things that you didn't really intend to. So inbound and outbound, and they do have to be applied. List is read from top to bottom, stops at the first match. The invisible implicit deny is at the bottom, so if you don't have at least one permit statement, you've just denied everybody everything, and I've seen that done inadvertently. Access control list is applied to an interface, not to the router, to an interface, either inbound and outbound. And the rules on the access control list is if you can have one access control list per interface, per direction, and we'll say per protocol, although the only protocol we really use anymore is TCP/IP. Some of the older routers, when you do access control lists, going to have DECnet and IPX and a lot of other things. The newer iOSs don't have those protocols in them. The older iOSs do. If you're still using IPX, you can use that, but the old rule was one access control list per interface, per direction, per protocol, so that we could have one inbound and one outbound access control list on this interface. Another interface, we could have a different access control list in and a different access control list out. They don't have the inbound and the outbound, can obviously be different lists. Packets are compared to each line that assesses the list in sequenced order from top to bottom, just like the other slide said. That's why the ordering of the statements is important. And oh, by the way, except for the new iOSs, you can't really change them effectively. You can't add lines to it. The new ones have the new iOSs have line numbers on it. The old iOSs don't. The way around that is to type them in Notepad, not WordPad, Notepad. WordPad puts some extra junk in there that will mess it up. But Notepad is a text editor. Write them in, and if you have something, just take it out. Use a no access list, whatever the number is. Then use access list, whatever the number is, and paste the stuff in. So copy and paste works really well on these things. Compared with the lines of the access list only until a match is made. That's why when we're trying to deny Dustin, we need to put deny his IP address at the top of the list, the very first statement, so that he gets to that one and he gets thrown out immediately. And then when Andrew comes in, that one doesn't match. He goes to the next statement, which says permit, and says, okay, he can get out there. Until we find out that he's doing the same thing, then we'll put his IP address up here also. Okay, so once a match is made and acted upon, no further comparisons take place. It doesn't look further in the list. That's why we couldn't do the permits at the top, the permit everybody, and then Dustin will go on to look, see if there was a deny later on for him. The system goes until it finds something that applies that statement and looks no further in the list. If you've got 1,000 statements and the first one is yours, doesn't matter what else is there. What's made an implicit denies at the end of the access list. If no matches have been made, the packet will be discarded, will be denied if there's not a permit somewhere in there. Now, I really have seen that one before. Standard access list, I've said this, filtered by source IP address only. Where's it coming from? Are you going to allow it in? And one of the things that we do when we apply these things, the standard access lists are applied close to the destination. Because if we applied it early on, we might wind up denying a whole lot more than we really wanted to. We'll look at that as we go through where would we apply when we look at the examples. Where would you apply the access control list? The extended list filtered by source IP, destination IP, protocol field, and port number. Source IP, source port. When you write these things, if you do a source IP and then a source port, or port, it's going to be the source port. Where you want to put the port, it usually is the destination if you want to permit or deny access to a particular resource. If we wanted to allow everybody to get to our web server, for instance, we would put permit any, nice term, instead of putting all 255, so 0.0.0.0, 255.255.255, that would be any, or you can just use the word any. To me, it's a lot easier to write. Destination IP 10.60.66.253 equal 80. The protocol field, or the protocol field TCP would have to have TCP in front of this. Protocol field TCP port number 80. That would then allow everybody to get to the web server that was running on that device. Named access list do the same thing as the standard and the extended, except instead of using numbers, and we're going to have a slide here in a minute that has whole bunches of numbers, you don't really have to remember them all. Instead of using numbers, we use names. It makes them a little bit easier to identify. You can name them based on the function that they're doing. Standard matches based on source address. The lower processor utilization of the effect depends upon the application. Extended based on source destination address, protocol source, the things that we've said before. Higher processor utilization, so the standard access control lists are going to take fewer resources from the device than the extended are. Reflexive is the established, that's the one we talked about. If you ask a question, you want the answer back in. A one-line statement, and if we did a one-line, and what it is permit established. If we did that, if we only did the one permit established, what's that going to do? Well, it's going to permit, and the established says that you established the connection. It's going to let your answer back in. What about everything else? Do we need to put any deny statements in? Maybe. Do we need to put any deny statements in? No, because we've already got the implicit deny. If we don't permit it, If we don't explicitly permit it, it's implicitly denied. Anything that you don't permit is denied automatically when you do this thing. Say what?
Kind of like you're being denied for a credit card.
Kind of like you're being denied for a credit card. Could be. Inbound access lists are, the packets are processed before being put into the router. This can save you some processing, and that's why we talk about, and we'll talk about why the extended closest to the source, the standard closest to the destination. There's a lot less information in the standard, so you can wind up denying a whole bunch of stuff that you didn't want to with the standards. Extended, you can deny close to the source, and you don't have to do all the processing. You don't use the bandwidth. You don't use the router process utilization as it goes through the network. Outbound are routed out of the interface. Inbound coming into the interface. Put your arms out. The interfaces are your fingertips. What comes in to your torso is inbound. What goes out is outbound. Traffic originated on the router is not filtered by the router. So that if I had denied ping traffic, for instance, ICMP, and I originated a ping packet on the router, it wouldn't, that access control list would not apply to that traffic.
So that's why I got a question.
Okay.
Like you try to ping, what is it, Microsoft.
They don't answer.
Right, you'll ping so far, and then it just...
Well, it goes there, it gives you the IP address, and you get a not available, or you get an ICMP message back, but you don't get the echo reply. That's the ICMP filtering. ICMP has, I don't know, 17, 16, 17, whole bunch of different things that you can filter on. Echo request is the ping packet. Echo reply is the answer that you get back. Network unavailable is an ICMP message that comes back. Host unavailable is an ICMP message. They basically, what they're doing is not sending the echo reply packet. They've just said on the interface in the access control list, deny echo reply. That's exactly what's happening. It is an access control list, and they're not responding to those. Guidelines, one access, we've already looked at this, one access list per interface, per protocol, per direction. More specific tests at the top so that we don't deny all of you guys instead of Dustin. New lists are placed at the bottom of the access control list. This is the one where I said you can't really effectively edit it. That's why you probably want them in a notepad. If we had our access control lists, and all of a sudden James decided he was going to surf porn. And we had 352 statements in our access control lists. And the second one said, permit the subnet that he was on after we had denied Dustin. And we want to put James up there as like the third statement. When we add him to the access control list, he can go at the bottom, which means it's never going to apply. If you've got it in a notepad, you can wipe out the existing access control list, put that statement in as the third statement, copy and paste it into the router, and it will then apply that. Access control lists, and we'll get to it here in just a minute, access control lists are applied to the interfaces separately from writing the list, which is kind of an odd thing. Because if you delete the access control list, it goes away, obviously. It's not there. But if you put it back in and you haven't unapplied it, that list will apply immediately. So it's a two-step process. First you write the list, then you apply the list. Yes?
Can you create like a script, like if say someone started downloading porn and...
You can in the more sophisticated, not here, but yes, but that'd be an application layer one.
Yeah, it would automatically
Yeah,
deny.
yeah. But that's a little more sophisticated than what we're doing with these. What we're doing with these are looking at the source and destination IP address, the source and destination port number. It's not really doing anything at the application layer. We're going to look at layer 3 and 4. Can you do those? Yes. Can you do that with these particular access control lists? No.
Oh, you're looking for an
Yeah,
automatic.
yeah, exactly. You can do that. Yeah, at the application layer, you can do that. New lists are placed at the bottom. Individual lines cannot be removed unless we save these things. And again, Notepad's a great way to do it. End access control list with a permit any command or a permit something command. Otherwise, you've just said no to everybody. Create and then apply them to an interface. First they're created, then they're applied, and it's a different command to apply it than to create it. To create it is access list, whatever the number is, and then a statement, permit or deny. When we apply them, it's IP access group in or out. The number, IP access group, whatever the number of the access control list is, in or out. So it's a different command, and on the VTY interfaces, it's access class. Don't know why they did it that way, but they did. That doesn't matter. That's the way it works. That's the way you have to do it. Do not filter traffic originate on the router. Standard access control list close to the destination, and you can use it or not. To me, SD. Anybody ever been to San Diego? Nice place to go, huh? Probably didn't like it. He was there. You were at the.
Oh, we went there before we left for our.
Yeah, before. Yeah.
446.
Yeah, but SD, standard destination, San Diego, that's just the way I remember it. Extended, go closest to the source. You can figure out your own ES. The lists, and again, we have a whole bunch of them. 1 to 99 are going to be standards. The one that you really need to remember for what we're going to do, unless you have a whole heck of a lot. And what somebody said, if you've got 1,000, and we go down here and they have some extended access lists, more numbers, so they needed more. If you've got that many access lists, and you got too many access lists, you can only apply one at a time per interface, per direction. It's not like you can write 99 of these things and have them working unless you've got one heck of a router. I mean, if you've got a router with 3 interfaces, the maximum number of access control lists you could apply for each, and we'll presume that we're only using IP. You could apply 6 of them, so that's all you would need. This is probably going to be enough, 1 to 99, and when we say access list 10, the system automatically knows it's going to be a standard access list. When we say access list 110, it's going to know that it's an extended access list, and that's actually as far as we go in CCNA. There are others. Andrew asked about MAC, and yep, 1100 to 1199, we can filter by MAC address. IPX, Standard Access Control List, and the newer iOSs, you won't see IPX in it. DECnet, the newer iOSs, you won't see DECnet in it because those are protocols that really aren't used anymore. They take them out as they go away. So we can filter on all those things, and down here we have the list 1100 to 1199, and then IPX extended 900 to 999. Don't know why they picked the orders, but that's the order they did. If we type access list 1, it's going to expect us to put a source IP address, a permit or a deny, and then the source IP address. If we use access list 100, it's going to expect us to specify the protocol, the source IP, and maybe the source port. The destination, you don't have to put a source port because typically you're going to, the source is going to be the random. You're not going to know what it is. It's going to be from anything. And then the destination IP and the destination port number. And that's the one that would allow you to do actual filtering. So creating a standard list, access list 10, deny or permit address to match any source. We can use any and host. We can use the host name. Host name if we're using DNS. Host name means that we're going to have configured the router to use a DNS server that can resolve that host name. Or you can, the ABCD, when you see ABCD on these things, it's an IP address. Any source, we can deny any or permit any. Probably not going to really want to do that. Well, that's not true. After we've done the specifics and we've denied Dustin, then we can go down here and just use a permit any. statement to allow everybody else to do those things. Oh, and we can use host. You can use the wildcard bits 192.168.3.6 0.0.0.0, or you can use permit host 192.168.3.6. Works either way. And if you use the 0.0.0 and you go back and look at it, it converts it to host anyway for you. Access list deny host 172.16.30.2. You can use, again, either that. We didn't use the host keyword 172.16.30.2. We'd have to use the wildcard bit 0.0.0.0. Check all of the bits to be sure that they match. Wildcards, we've looked at those things, and I think I've talked about those things. What it says is if it's a 0, check it. If it's a 0 in the 8 bits that we're using, if it's a 1, I don't care. Doesn't really matter. So you can use host, network, or part of a network. You can use parts of a network, and he is big on blocks. Blocks are how many bits? We have 2 bits, 2, 4. The wildcard mask is always going to be an odd number, and it's going to be 1 less than the block address, or how many addresses are in there. If we have 4 bits, 2, 4, 8, 16, the wildcard bits would be 15. Odd number, 1 less than however many host addresses that you have. So host addresses minus 1 is going to be whatever the wildcard bits are. Because in the 255, we actually have 256 addresses in there, right? 256 minus 1 is always going to be an odd number. There's rules, and 2, 4, 8, 16, 32, 64, and it's got to be in those. So if we have 4, the bit's going to be 3, 8's going to be 7, 16, 15, 32 is 31, 64 is going to be 63, would be the bit number. If we had 128, it would be a 127. The range in this one, 172, 16.15.0, block size of 8, 0.0, 172. If this one was in the range, 172.16.8, 0.0.7.255, you can put the ones any place that you want. One of the kind of interesting ones, and think about this one, what if you wanted to deny all of the odd addresses on a network? How could you do that? If you know, I always wanted to provide an access control list, one statement to deny all the odd addresses. Huh? Now this is another exercise to see what the bits do. What number do all odd numbers have in them? 1? Has a 1, right? So what do we put in the 1 bit? In the wildcard mask. If we put a 1 in the 1 bit, if we put a 1 in there, what does it say? I don't care. So we need a 0 in the 1 bit, right? Which would be what for the mask, for the wildcard bits? I don't care, I don't care, I don't care, I don't care. Oh, I care about that last bit, so it'd be like 254, right? So 0.0.0, try it out. Game it, see. 0.0.0.254 should, if we put a deny, should deny all of our odd addresses. And that's just a way to go through that mentally to see what these wildcard bits actually do. They check the zeros and ignore any ones in the address, in the wildcard bits portion of it. So yeah, that's one, and I don't think it's in this book. It was in the old book, one of the labs to do there. This is just an example here, access, or 172.16.10.0 network over here, the 20 network over here. Access list 10 deny 172.16.10.0, 0.0.0.255. Access list 10 permit any. We deny the Class C portion, so we deny 172.16.10 network is the deny, and then we've permitted everything else. And then we would go to the internet interface Ethernet 01, IP access group 10 out. What we're doing is denying the 10 network access to the 20 network. Why will we apply it on this interface going out? Why not put it here on the E0? See if I can make this thing work and draw on this thing. This says to put it on this interface, right? Why? What if we put it on E0? What's going to happen? Traffic's going to come here and it's going to go nowhere. You can't get to the internet now either. Because you've denied access to the router. Which interface are you going to put it on? We would really kind of like the internet traffic to be able to go to the internet, true? But we don't want the traffic to go across here, so we put the deny statement on this interface. It can get onto the router. The router will send the internet traffic to the internet, but won't let you get to payroll, for instance. So which interfaces do you want, where do you want to apply those? Where you apply the list is important, as well as the order that the statements go in. Now let's see if I can get this thing turned back off. Without an access control list, anybody can use the Telnet. We've talked about that one, controlling access. We can control access to our VTY ports as well as to our Ethernet ports and our serial ports, as well as to those that pass traffic. When we apply those things, when we apply an access list to an interface, an Ethernet or a serial, it's access group. When we apply it to a virtual terminal, to a VTY connection, it's access class. That's the only difference. That's the difference in them. Yes, there are different commands, and I'm not sure that anybody, I've never read why they picked those particular statements, but that's what they are. It's one of those, it is what it is kind of deal, and we're not going to change it. An example, Lab A, configure in the config access list 50, permit 172.16.10.3, line VTY04, access class 50N. And you really want to configure these things as in because you don't want people to connect to it. If you configure it out, you may do some really weird stuff to your connection because now you've applied, and I guess what you've really done is you wind up denying yourself access to some other thing. So you really want these things applied on inbound. Everything has to be applied as either an inbound or an outbound. And then we get the implied deny. So this one would permit, for instance, would permit Patrick to Telnet to his router, and only Patrick to Telnet to his router, and would keep James off of it. Would keep me off of it, would keep the rest of us off of it. Because instead of just using, we've got to go through the password stuff, but instead of being able to go through and try the brute force password after password after password, it just would not let you initiate the connection. Allows you to choose the source, and the extended, we've talked about IP source address, IP destination address, the protocol, and the port number. And you get a source address and a source port number. When you write these things, if you write the source IP address and the source port number, it's looking at the source port, not the destination port. If you're trying to allow people to get to your web server, you would permit at the destination IP address, and the destination port number would be 80. The source port you can leave blank, and it's any port then, or you can use greater. You can use greater than or equal to. You can use greater than 1024 because that's where the random ports are going to be assigned. Protocol lists, IP, IPX. Again, we're not going to use that anymore. Extended MAC, IPX, protocol type, TCP and UDP are generally going to be the ones that we do. Dynamic lists of permits and denies, and dynamic is beyond what we're going to do. Dynamic are the ones that change automatically. What we're going to use are permit and deny statements. each operating system has its own word in here. Some of them are allow, some of them are permit. Cisco's are deny and permit. It doesn't matter if you go to a different device, different manufacturer, you can do the same process. It's just that you're going to use different words to do that thing. Extended access control list, these are the keywords, EIGRP on down, and when you use port 80, they didn't go far enough, but when you use port 80, you can use 80 or www. If you use 80, he'll convert it to www. I usually use the port because that way I don't have to memorize what their words are. If you like their words, that's good. Select an access list, router A, access list 110. Decide on a deny or permit access list 110. Access list 110, deny. And then you have to deny what protocol. And if you go through these things and use the question marks, it'll tell you what you've got to put in here. Protocol typically going to be TCP or IP, UDP maybe, ICMP. IP, TCP, UDP, and ICMP are really the ones that we're going to use. ICMP for the ping stuff and the ICMP messages. Choose a source, IP address, deny TCP any. So we're going to deny everybody this one. Choose a destination IP address, TCP any to host 172.16.30.2. Choose the type of service, port and logging, equal to 23, so we're not allowing Telnet to that specific location. Once we've done this, what do we need to do? Because what kind of a statement is this? What happens if we don't put a permit in? And you still can't get there. You can't get to anything else there. After you do your denies, do a permit. And you need this, the most specific. This is pretty specific, right? Because we're going a specific host, a specific computer, and a specific service on that computer or on that router, perhaps. And then we have a permit IP any 0.0.0.0.255, permit IP any source destination. And they just did that to show you that if we use 0.0.0.0 means any network, and 255.255.255.255 says ignore everything. That's the same as typing any. In my humble opinion, it's a whole lot quicker to type any there than it is to type any and all the zeros into the 255s. IP access group 110N. The access group number matches the number of the access list. Access group tells us it's on an interface. Access class, it would be a VTY connection, a virtual terminal connection. Named access lists, again, do the same thing, except instead of access list, you say IP access list, and you have to specify standard or extended, and then whatever you want the name of it to be. All the rest of it's going to be the same. Except when instead of going to access control list, it goes to standard NACL, named access control list. That's the way you know, and the statements are going to be put in exactly the same way as if you use the numbered lists. Monitoring, show access list 110, show IP access list. And the show access list and show IP access list, I think, do exactly the same thing. Show IP interface, which interfaces have access lists. Show access list will show you the lists, list the statements that are in it, and tell you how many times it's been invoked. If it's a deny, tell you how many times it's been denied. If it's a permit, how many times traffic has been permitted with it. This is the example. What I'm going to do is stop here and take a break. I know you're ready for it. And finally. And then when we get back, we'll do these, and I have this topology configured, including a cloud using frame relay. I did add something over here. Don't put the thumb down on frame relay. It is the one protocol that is predominantly used right now. It has some real advantages in that you buy a minimum whatever you need for bandwidth, and if there's any extra, you get to use it. Kind of handy. But I did add over here, since he says down here deny CBT nuggets, and out of my simulator I can't get to CBT nuggets, I added a web server over here so that we can control access to it. through the internet cloud. Are there questions at this point? When we get back, we'll go through these things. The only way to learn how to do access control lists is to do access control lists. They're not shouldn't be, hopefully, as confusing as most people want them to be. They're just a list of who can get in and who can get out based on IP address, port number. Okay, let's take a break then.